Hello everybody. For those that watched my last video, my kid was okay. She just dropped her desk chair very loudly. No crying, no injuries. So all is well at the Schneider house. Hope everything's good at your houses too. Here we go, page number 7 of your Regents Review packet. So we're gonna start right off with a trig graph, which we have covered. You guys should know how to do this one. Which sinusoid, which is just a fancy name for a sine graph, has the greatest amplitude? Now remember guys, what is the most important part when you're looking at a sine or a cosine graph? Find the midline. All right, so just because this sucker goes up to 7 does not mean its amplitude is 7. So what I would do is I would say, okay, 1, 2, 3 is the low point. 7 is the high point. 1, 2, 3, 4. So halfway would be at 2. So there's your midline. So an amplitude is based off of your midline. How high or how low does that graph go? Amplitude is 2. All right, same thing for here. The lowest it goes is -5. The highest it goes is 3. So 1, 2, 3, 4, 5, 6, 7, 8. Halfway would be 4. 1, 2, 3. Here is your midline. And your amplitude goes off of that. So from here, how high, or from here, how low did you go? We went 1, 2, 3, 4. This amplitude is bigger, so we know that this is not, well, let me cross it off here. That's not my answer. When you are given an equation, what you need to know is the amplitude is the very front number. So the amplitude of this graph is 3. That is smaller than 4. Not you. And number 4, the amplitude, although it tries to trick you here, the amplitude is 5. All right, this negative is just telling you that off of your midline, the graph is going to go down first. Remember, it's a direction, okay? So the amplitude here is 4, amplitude here is 5. This one is bigger. Okie dokie. Number 19, consider the systems shown below. The two solutions can be described as both imaginary, both irrational, both rational, one rational, and one irrational. We can do this algebraically. You guys hate it. So how can I get around this using my technology? Oh, that stinking light again. There we go. So I am going to graph them. Nope. Let's try again. Home. Graphy, graphy. Now remember, our calculators are able to graph pretty much anything we want. So the first one is a linear function. So in order to graph this without solving for y, all I'm going to do is I'm going to hit delete. And as soon as I do that, I'm going to choose number 6, relation. And the reason I do that is because it gives me a wide open entry line that I can type whatever I want. The linear function is 2x minus y equals 4. There's your linear function, and it's nice, you can see it. So then I'm going to hit the tab button, bring my entry line back up, and notice it's already set for a relation. It's all set without anything having to be deleted. This second equation here is actually a circle because it has an x squared value and a y squared value. Okay, it's not a parabola because the y is also squared. So I am going to enter that one as well. X plus 3 squared plus y squared equals 8. Boom. Oh, there's the circle. Now, the solution to any system of equations is where these two equations cross. Well, we got a little problem because these two graphs, these two functions, never, ever cross. So therefore, because they do not cross at all, our answers are going to be imaginary. Like I said, I can show you this algebraically, but I think most of you will probably go to that graph. Okay, if you want to see it algebraically, drop me an email and I will write it out for you and email it back to you, okay? Number 20, which binomial is not a factor to this beautiful cubic expression? You can do this again several different ways. You can synthetically divide by -2, -4, +6, and +7 to figure which one comes out with a remainder. Or if you want to be a little bit tricky on this one, you can graph this cubic polynomial. All right, so that's what I'm going to do because I think that's an easy way to do it. Okay, I'm having a hard time. There we go. It was, what is it? X to the third. Get out of there. 11x squared, 16x, and 84. Now, this is going to be probably kind of gross. Oh, not horrible. I mean, you don't see all of it, but you can see that it's a wormy. Okay, so the question is, which one is not a factor? So if I go to menu 5.1, I graph trace it. So remember, it was x plus 2. So the factor would be negative 2. So in trace, if I hit negative 2, if I hit the up arrow, it'll give me the little 0. That is a factor because it hits at the root. Okay, so I know this is a factor. This one, the root would be at negative 4. So here we go. I'm going to hit negative 4. See how it pops up there? Boom. Whoa, that is definitely not a root. So this one is not a factor. Hi, Abs. Let's just check out these other ones. It's going to be positive 6, and we're going to hit at positive 7. So let me just prove it to you. Positive 6, boom. Hit the up arrow. It's a 0. Positive 7, boom. Hit the arrow. There is another 0. Okay, so those ones are solutions. Not solutions, I'm sorry, factors. This one was not a factor. All right, last one, certainly not least. Again, I've crossed it off. We have not covered this one yet, so here is your teaching. Ball is dropped, height of 32 feet, bounces and rebounds 80% of the height from which it was falling. What is the total downward distance in feet the ball traveled up to the 12th bounce? You can actually calculate this using that formula that I gave you in 9th grade or Algebra 1, okay? 1 times, or I'm sorry, starting amount times parentheses 1 minus the percentage, close it, raised to time. However, if you pick out what is the total distance, total being like the key word right here, there is a formula on your reference sheet that will calculate the total amount something has traveled, the total amount that's in your bank account, the total amount someone has earned at a job over a span of time. That formula on your reference sheet is S sub n equals A sub 1 minus A sub 1 times R to the n power over 1 minus R. So these should look familiar based on Algebra 1. All right, so all we really have to do is plug in numbers into this formula. This stands for the total amount. So the total distance this ball has traveled is going to equal A sub 1. That is the first number that the ball was recorded at, and that ball was recorded at 32 feet. So that is what's going to go in for A sub 1 every time I see it. Minus A sub 1 again, 32, times the rate. The rate is your percentage. Where is it? Your percentage. The only deal, just like in Algebra 1, you have to change that to a decimal. So 80% is 0.8. N is what number we're looking for. We're looking for the 12th bounce over 1 minus the rate again. So notice R, same number. Once you have everything plugged in, guys, literally it is just as easy as picking up your calculator and typing it in. Okay, home calculator. Let's bring it over here. I'm going to bring up, oh good Lord, fraction. So it was 32 minus 32 times 0.8, the 12th bounce, 1 minus 0.8. And the total amount that this ball will fall after the 12th bounce is 149. Boom. There it is. Easy peasy. You just got to recognize it, okay? Like always, if you guys have any questions, drop me a line. Let me know how you're doing. I miss you guys all, and I will talk to you soon.